That's why I got to stare at it. Too harsh. All right, first diagram up here. First diagram. What do I have up here? ADE and ABC. Those are referred to as, just want to review our vocab again. Those are both, never mind, what am I doing here? You guys wish. Okay, let's try that again. All right, those are both, Gabby, good talk, Gabby. Thomas, what are those both up there? Those are called? Secants, good job. And then over here I have BCD, which is a secant, AB, which I call a, Gabby, you're on fire. You owe me a couple. You're listening to this. Thomas? That's a tangent. Both are going to be found the same way. To find their lengths, they're found the same way. And this is going to be a little awkward, but I'm not going to give you a formula. I'm going to give you an expression to remember instead. All right, an expression. So we'll start it off here. To find lengths of secants and tangents, chords we did yesterday. So to find the lengths of secants and tangents, you're going to remember a phrase for me. Whole, with the W, times external. Let's play a little word association game. External, what word do you think? Outside, thank you. Whole times external equals whole times external. What are you talking about? Let me teach here. So anytime we're dealing with a tangent, secant, that's just how we're going to find the length. Now, what do I mean by whole and external? Look back at my two secant diagram up above. Somebody name one whole secant, please, using the letters. Name one whole secant up there. One whole secant. Ian? EDA. Okay, EDA. I'll just call it EA. So what I would do, I do EA times external. What's the part on the outside of EA called? Part on the outside of EA? Ooh, Doyle? AD, good. So I would do EA times AD, whole times external, equals, same diagram, go to the other whole secant, name it. What's the other whole secant's name? Here we go, Haley? CA, perfect, times its external part, which we're going to call, whoa, there we go, Thomas on fire, this number generator likes you. BA. See what I mean now by whole times external. Go to the other diagram now. Nothing changes. Just watch what happens when we involve a tangent now. Let's start with the secant, though. Give me the whole secant's name on this diagram. Whole secant's name, Amy? DCB, DB, times, how about its external part of that secant? Amy again? CB. All right, now let me slow it down. Look at the tangent. Whole tangent, AB. What are you going to tell me about its external part? Same thing as the whole part, isn't it? Because it's all on the outside. So when you do a length of a tangent, those two values, whole and external, will always be the same. Okay, whole and external will always be the same. So just keep an eye on that when you do a tangent length. Anything about whole times external until we put some numbers on it now. All right, before we start putting numbers on it, I have one fear. Big fear. And that's part of the fear. All right.
That's not a clapping moment.
What?
That's not a clapping moment.
Not for me, it's not, no. Because that makes you happy, which makes me miserable. There's always opposite reaction between you guys and myself. All right, let's go.
Slide left, slide
All
right.
right, you guys.
Genie. Samuel. Curl. Curl. Book. Curtain.
Drop.
Ooh, you guys all right? You guys all right today?
Fade.
Spin.
$16.
Page girl.
Swing.
Anything we're missing? All right, let's roll. Swing. Spin. Clock. Fade. Cubes. Drop. Curtains. Book. Curl. Shatter. Wipe. Left. Right. Genie. Pinwheel. Star. Flip. Okay, here we go. I had a bad feeling about today because a lot of these answers are just single numbers. And so, all right, here we go. Shatter or Promethean person? Does your luck continue or does it just start going dry? Shatter, Promethean person. I'm so heated right now. I don't even want to continue teaching. You ever heard of those rooms where they have like a whole bunch of glass stuff and you get to take a bat and just go in and just start going nuts there? That's what I need right now. That's what I need. Despise all of you. Here we go. All right, let's see if we can get through this. All right, number one. All right, I was talking before we were rudely interrupted about my biggest fear, and that is you're going to treat this like a chords problem. 4 times x, 5 times 10. You got to make sure you know it's secants. These are not part times part, whole times external now. Whole times external. All right, here we go. I don't know what I'm going to do if something, I don't know. I'm just going to just give up. I should just be wearing pajama pants, socks and sandals, pushing handicap buttons to get out of the door.
What do you have against socks and sandals?
It's not a good look. Socks and Crocs, not a good look. It's not. We both know this. All right, Thomas, back to you. How about give me a whole secant length? 15. How about its external part of that secant that's got a length of 15? Josh, external part.
5.
5, good. All right, how about the whole secant on the other one? Now you're going to have to combine some terms. Give me an expression here. Other whole secant. Here we go. Haley. 4 plus x times, how about its external part there? Ooh, Charlie? 4, good. All right, so that's how the whole times external part's going to work. If you didn't take notice, look at the directions up top. It does say round to the nearest tenth, please. $14.8. All good? All All right, now we're going to do a tangent here on number 2. So just like we talked about earlier, when you do a whole times external for your tangent, it's both the same value since it's all on the outside. So y times y equal to, how about the whole secant length there? Whole secant length. Kissinger, what do you have? Whole secant length.
11.
11, good, times its external part. Josh?
2.
2, there you go. Okay, hopefully we're putting y squared here and not 2y. If you put 2y down, you might want to leave this classroom immediately because you're an embarrassment to the math community. All right, y squared. Sorry, some of you better erase that quick before I get you out of here. Square root, and then yes, round to the nearest tenth. So what's that one? 4.7. All right, let's keep going. 2 secants now. Again, I know it's easy to look at it and do maybe your brain does part times part, but you got to do whole times external. Give me one whole secant here. One whole secant. Gianna, one whole secant for me. Good job. And then what I have to multiply its external part. Its external part, Zoe. 8. All right, be careful here. This next whole secant, got to combine some like terms where you tell me how long it is. How long is it over here? Going back. Kissing you, what do you have? Whole thing, yep.
Y plus 10.
Good, y plus 10. Combine your 7 and 3. And how about the external part there? External part, Amy?
7.
What do you want? Like, I don't know. What do you want me to do here? I don't know.
Tomorrow.
What do you want me to do? Sure, why not? I'm already so deep in it. I'm already so deep in it. Go ahead. I got rid of it. I'm just going to leave it up here because it'll probably happen again. Slide right, slide left, genie, curl, swing, cube. I don't even care anymore. Shatter, drop, fade, star, curtains, swing, already got there. Drop, yep, wipe, book, clock. I already have cube, flip, spin, yep. So genie already up there. 1, 2, 3, 4, 5, 6, 7, 14, 15, 16. All right, here we go. Oh, it's right up there. Spin. Two spins, flips, clock, book, wipe, curtains, star, fade, drop, shatters, cube, swing, curl, genie, slide left, slide right. Okay, you got to vote. Here you go. I'm not pulling this business. Spin. Spin. You got to vote for one of these 3 now. Spin.
Just
One. I'm not playing the game. Nope, you already have no homework. 1. I'm not going to fall into the trap. 1, 2, 3, 4. Good try, though. So I got 4 here. How many for shatter? 1, 2, 3, 4. Oh, you're going to keep doing this. Fine. All right, so that means if I got 8 here and there's 16 people in the class, actually there's 14 people in today and already 8 have voted. So just doing that quick math, that would mean 6 people are going to go for swing. All right, so we're going to go swing. Here we go. Even if you're going to raise your hand or not, you have no choice. So good try, though. 6. All right, here we go. Swing or Promethean person. Here we go. Swing or Promethean person. Can we get this over with? Okay, somebody is somebody is messing with me. There's no way 3 in a row. I did not turn it. Who is There's no way. Somebody was in here. It came in here. All right, somebody's got to fess up because it's not me. That was a good job though, but it wasn't me. Anybody want to fess up here?
You get a point for the quarter. You read it, that's not, it's not me. But if I snitch, can I get a point?
Oh, if I snitch, can I get a point?
I have
No.
I don't know.
So this has all been rigged. That's what I'm
I
hearing.
didn't do anything.
No one
was
changed
all
it.
natural. Nobody-
I was in here when
Well, you're
everybody.
bugging.
Oh, actually, no, I wasn't. I was out in the hallway. So somebody came in. So somebody could have done something here.
What do you want, bro? Like,
All right.
So who was it? All right. How about this? I'm not going to give the no homework tonight unless somebody tells me
You wouldn't give it anyway.
who this genius
will we
is.
get
You
it?
wouldn't get it anyway.
No, I will give you no homework tonight because of the guts and audacity of this person to do it. I will give you no homework tonight, but that is it.
Will they get in trouble?
No.
I did it.
Okay. Credit. Right before what? When I was in the hallway?
What?
Right when I was in the hallway?
Yeah.
You just came in and did the.
Yeah.
All right. All right. Just wasted all that time with me. And everybody else knew. And just played along here.
I didn't know.
It was like
There were only like 3 people in the classroom.
Okay.
That's none.
See, it would have worked if I didn't hit another number again. Like the answer was somebody's number I called, it would have worked.
You put it on none or random.
I just put it. Oh, I just
Put
put
it
it
on
on.
none. He's hoping that.
There we go. All right, I will keep the no homework tonight because that was clever. You had me. All right. I would have never known unless, like, if I didn't pick another number, we didn't go through this whole spiel again. I would have never known somebody rigged it.
Wait, but then we would have gone with the next one, would have been Promethean person, and then we would have.
But I would. I'm not planning on teaching my 7th period class. Actually, yeah, it would have been. The next slide would have been it, and then I would have gotten a little. But respect. Absolutely not. All right. All right, we ready? Did we solve this bad boy? Six. We're going with the 6 here. We're good. Could be done with the lesson now.
What time did we finish like the lesson for period 2?
They finished their homework. They had enough time to finish it. So that's it. Yeah, 'cause it's easy to do nothing, right? All right, here we go. Number 4. I like number 4 a lot because I'm combining yesterday's class with today. Does everybody see? Well, first, let me ask you guys, what's Y labeled as? That's a what?
4.
Y is?
Wait, nah. Tangent.
That's a tangent, right? Also, does everybody see the secant? Not only that, what else do I have in the circle as well from yesterday? I have chords. So what I want to do with you first is don't write anything down because I'm going to erase it on my sheet up here. I'm going to do whole times external right now. Watch where it leads me. Y times Y, everyone agrees? Now look at the whole secant. If I called on one of you right now and said, hey, give me the whole secant length, what variable would it have in it? X. And everyone see the problem? I'm going to have Y on the left side, X on the right side. That's not going to fly. So I cannot do whole times external. All right, I cannot do whole times external. Instead, I'm going to have to go back to the chords you told me about and do RP being intersected by chord and M. Part times part. That's how we're going to get through this one. All right, so does everyone agree? I can't find Y because I can't do whole times external. So now I'm going to have to do 2 chords intersecting each other. All right, give me 2 parts of one of the chords there. 9. Here we go, Ian. 2 parts of one of the chords.
3.2. So.
Yep, 3.2 times 10 equals. Now give me the other chord. Give me those 2 parts that it's broken up into. Ooh, Zeev, good talk, good talk. Thomas, back to you. 4 and X, yep. You cannot mix secants and tangents with chords. You can't mix them up. Chords stay with chords. Tangents and secants stay together. So we have 32 equals 4x. X equals 8. Now substitute 8 in for x for me. Substitute 8 in for x so we can do whole times external now. So I have y times y. How long is the secant? The secant we identified. How long is the secant? Ian?
20.
Is that new math?
4 plus 8.
Yep.
12.
Yeah.
Oh, 18. Oh.
There we go. Yeah, 18. And then how about its external part? I can't keep doing this. Thomas?
Can we get the homework for tomorrow if we do it again?
No, I'm not doing this. You ruined it already. I'm not going to go. We're done. You guys got no homework. Live with it. I could have rescinded it, but I'm not, so I'm just going to keep going. All right. Y squared equal to 108. Go ahead, take the square root of both sides. And what do we got there? 10.4. Okay, any issue with that one? I like that one a lot. All right, next one. Buckle up for this one. Now the tides are going to turn. We're going to go miserable on this side, happy on this side now. All right. Let's do the geometry part before we get to the algebra part, which will make you miserable. We got a tangent and a secant. So tangent, 10 times 10. Whole times external. How about the whole secant here? Whole secant length. There we go. Aiden?
X plus 4.
Yep, 2x plus 4. Combine our like terms before I write it in. And then how about the external part here? Aiden again?
100. Wait, oh shoot, X.
Yeah, relax. I got x. Everyone's good? All right, that's the geometry part behind it. Now let's do the algebra part. 100. All right, looks like we're going to have to do some distribution here. 2x squared and 4x. All right, what's your move now? We talked about this yesterday when we did chords. We had a problem like this. Not exactly like this, but no square rooting, right? No taking the square root because you have an x squared and an x in the same equation. So what is going to end up happening here eventually? Not square rooting, but when I have an x squared and an x in the same equation. That's what I was thinking. Factoring, yep. But as we know from yesterday and all year long, you can't factor anything unless
0.
equal to 0. So let's move that 100 over. So 0 equals 2x squared plus 4x minus 100 when you move it over. All right. Look, I've done a lot of factoring with you guys, but we have not done anything that looks like this factoring. The only time I've had you guys factor this entire year is when that first number is 1, not any other number. Whatever's with the x squared was 1. That's the only time I had you factor. You cannot go numbers that multiply to a negative 100 and add to 4 here. You cannot do that unless that number is 1. So are we stuck, or does anybody have some suggestions here? Divide everything by 2. Now, if you're on a homework or a test and you divide by a number, you have to divide everything by the number. All right, just not what's convenient for you. So if we're going to divide by 2, we got to divide everything on the left and everything on the right by 2. Will it have any effect dividing 0 by 2? It's just going to be 0. Here we go. Divide the first term by 2, you get x squared. Second term, you get 2x. And third term divided by 2, you get 50. All right, now there's a 1. Now we can play the game now. So I'll give you guys a minute or two. You're finding two numbers that do what? Yeah, multiply to negative 50 and add 2. 2. Have fun.
Wait, so you're not allowed to divide the 2 in the second step?
I could have done it there too, Matt, yeah. But like I said, Matt, if you're going to do that in a problem, it's got to be everything. Like say that was 5x instead of 4x, you still got to divide it by 2 then. Okay? So you got, if you're going to choose to divide by a number, you got to divide everything by it. So looking for two numbers that multiply to negative 50 and add the 2. Waiting. Still waiting. We only got 5 minutes. Nothing for me? That's good, because there are no numbers. Now, does that mean there's no solution? No. All that means is that's not factorable. And if something's not factorable, we have something we could always rely on to solve it. Anybody want to chime in with it? Oh, not so happy now, huh? Not so fun and games, Mr. Promethean Man, not coming up 3 times in a row, huh? Not fun times, kids. What do we have to use here? Yes! Quadratic formula. Wednesday, 5th period. Anybody have it? Or are we going to have to create this as a village?
X equals
Okay, good start. That's what I wrote up on the board.
B. 2AB.
Negative b plus or minus the square root of b squared
Whoa,
minus 2ac over 2a.
whoa. There it is. And lucky for us, all we need to do is substitute in the correct numbers because we could type it in our calculator all at once. But we got to substitute in the numbers correctly. Ready? What is our b value up here out of these 3 here? 1, 2, and negative 50. 2. So ready? Put it in parentheses. Negative, parenthesis, 2, plus or minus. Put the 2 in parentheses again, squared, minus 4. How about your a value? 1. C value? Negative 50. All over, and then make sure it's all over in your calculator, just not the radical part. 2 times the a value of 1. Now, as you guys are typing that in right now, remember, you don't have a plus or minus button on that calculator. So you're going to have to do this calculation twice in your calculator. Once for plus, once for minus. Okay, so it's got to be done twice. Let me go writing everything up, even though you do is going to be the funny thing. Got me. I'll remember that as I'm grading quiz 3 on Tuesday. I'm getting a positive 6.1 for one answer. User error if you're not getting that one, right? Positive 6.1. And then the negative answer you should get out as negative 8.1. We still got time here, so we're going to have an awkward staring contest. Can't have negative 8.1, right? Okay, I have a diagram, and a segment length cannot be negative. So we are going to reject that and just accept the 6.1. And I think we'll have to do 5 at the beginning of class tomorrow since you've milked this class so much today. And I let it happen. Now I have to add one other thing I got to do every day now before class and check the paper.